Okay, quadratic formula. Raise your hand at home or in the classroom. Do you remember that you did the quadratic formula at the very end of the year last year while you were at home remote learning? How many of you remember that you've heard the word quadratic formula? Does anybody happen to remember what the quadratic formula is? Well, we're going to get there, and it's an important one. We are going to want to memorize it. This will probably be one of the things from your public school education that you actually do remember 20, 30, 40 years from now, regardless of what job you go into, because it gets used a lot. And you must take good notes today. Even those of you that hate taking notes, you are going to be expected to derive the quadratic formula many, many times on your homework sets. So we need to make sure that you do it right. And what I am seeing on the board is very helpful, because one of my questions was, we are going to use this to solve a quadratic equation. And a quadratic equation is when we have something times x squared plus something times x plus some number by itself equals 0. The quadratic formula says that means x is one or more answers or no answers at all. So a little bit more vocabulary. Roots of those quadratic equations. Roots is a synonym for solutions, answers, zeros. So anytime the directions say those, it's all the same thing. You've done synonyms plenty of times in your English classes, I'm sure. And we just talked about this is the quadratic equation if it is equal to 0. And the quadratic formula will let us solve that. X squared has to be the highest power. The formula, and I want you to write this down because then we're going to memorize it, is if you've got a quadratic equation and it must equal 0, otherwise you'll have C as the opposite of whatever it really should be. And the quadratic formula is that your solutions x is opposite of b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c are those numbers in the equation. I don't know if these still are active or not. And I know this will be hard to hear. Okay, hyperlink isn't working, but search YouTube and you can get some cute little songs. I will not force you to listen to my terrible off-key singing, but search YouTube for quadratic formula songs, and that may help you memorize it. Anybody still getting the formula copied down? We're going to use it, and then we're going to derive it. Wave at me if you need to wait. Okay, not quite there yet at home. Okay, are we good now? Yes, but you will miss content for which you're responsible in terms of the question in the chat. All right, to use the quadratic formula, we have to first check, does it equal 0? Yeah, so we're in good shape. Then we need to identify A, B, and C. So this is going to be A, whatever is times the x squared. B is going to be the -5, and C is going to be the +4. So make sure that it's in the right order, that you've got the x squared first, then the x, then the constant, so that you can identify those correctly. So then all we have to do is to plug in. Our formula was the answer x will be the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The opposite of b is going to be a +5. That does not mean b is always negative. We take the opposite of whatever b was in the formula. plus or minus. B squared is going to be negative 5 squared. Be sure you're careful when that's a negative, because negative times negative is positive. The first thing inside that square root sign needs to always be a positive because of the square. Then we're going to have minus 4 times A was 2, B was minus 5. Then I like to count how many minus signs do I have in that part. I have the minus 4, and I have a positive, and then I have another negative, and 2 negatives means I need a positive right there. I think. Did I do that right? Oh, I'm half asleep, aren't I? I wrote down B where I needed to write down C. Sorry about that. Let's fix that. I knew something didn't look quite right there. Okay, let's go back to the minus 4AC. Minus 4, so I keep that. A was positive 2. And here's where I made my mistake before. C was not negative 5, C is positive 4. Now when I count those minus signs, I only have 1, so this is a negative. 4 times 2 is 8, times 4 is 32. And that needs to all be over 2A. So 2, A was also a positive 2, so that is all over 4. Now we simplify. 5 plus or minus the square root of 25 minus 32 is going to be a negative. And specifically, it's going to be a negative 7. And that is all over 4. What happens when I have a square root of a negative? Ryan, what happens with a square root of a negative?
You have to use I.
This needs to become imaginary. So what I have is 5 plus or minus the square root of positive 7 times I all over 4. When it is imaginary, I can't leave it all together. I have to separate real and imaginary. So this becomes 5/4 plus or minus the square root of 7 over 4, and then an I out to the side after that. Those are my 2 answers for X. Any questions on that one? Okay, let's do some more. I'm going to teach you how to do this on your calculators as well, which means I need to get my calculator powered up for us. So, this is the same equation, 2x squared minus 5x plus 4 equals 0. We just solved that and got 2 imaginary answers. Now, instead of 0 equals that, I'm going to say y equals that. Does that much make sense to everybody? Then we want to enter that on our graphing calculators as a function. So grab your calculators, type in for a function, not a relation like we were doing yesterday. Okay, there, mine decided to work. Let's see, can I pull this? Okay. All right, so I'm going to type that in. So I need to be on either a scratch pad calculator page or a document, scratch pad graphing page or a document graphing page. I'm just going to go to my scratch pad and see if I can get it to cooperate here. Okay, so I'm on my calculator. I've got f1 of x equals, and I'm just going to type in the 2x squared. Let's see how I can get this to all show up for us. Okay, so And then I'm going to go down to the bottom where I have the x, and up to the square button right beside the 4, minus, I am subtracting, 5 back to the x, plus 4, and then I'm going to hit enter so that it draws me a graph. Notice that does not have any x-intercepts. It does not cross the x-axis. When you have, so our graph, if I copy that over here, our graph is going to look something like this. And it has no x-intercepts. Because, now when we just solved it with equals 0, we got imaginary solutions, right? We had an I in our answers. Yes? See some heads nodding? We got I's in our answers when we solved it with the 0 in there. We did not get any real numbers, just imaginary numbers. Now I said zeros, roots are the same thing. We changed y to 0. So on this graph, if y equals 0, I'm talking about points along the x-axis, right? There are no real numbers that work for y to be 0 in this equation. So because the related quadratic has no real solutions, I can't get any points on the x-axis because y can't be equal 0 for any real numbers. You're going to start having homework problems where you have to do that to be able to answer that. You have to be able to draw this on your calculator. One other thing we're going to ask you to do is, what's the vertex? What's the point where that quadratic turns? To do that, best friend button is menu. So click menu, and then click that you want to analyze your graph. And then, in this case, that vertex is the lowest point on the parabola. So for this right side up parabola, we want a minimum. And then it's going to ask us for the lower bound, so we click somewhere to the left of the vertex, somewhere to the right, and it says, oh, that point, that vertex is 1.25, 0.875. So on your problem set papers, you will label that 1.25, 0.875, because that's a critical point on that. So are we ready to try another one? The more of these we do, the more sense it makes. Okay, this one, use the quadratic formula to find the roots. Is it in the right form? Maddie, what do you think? Maddie, Paul? What do we need to do first? Is everything in the right place?
No, you need to move the 3x and 28 over so they're on the same side as the x squared.
Excellent, thank you. So we've got to get it equals 0 is the first thing we check for. That means we need to change the signs of the other two things before we go on. Now quadratic formula, x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. b is negative 3. I need the opposite of b, so I need positive 3. Then I am going to have b is negative 3, so I am going to square that, which gives me a positive 9 as the first thing that I have there inside my square root sign. Then I need, let's see if I get it right this time, minus 4. A is just a 1. C is a minus 28. all over 2a, so that's 2 times 1. So I said my minus 3 times minus 3 was plus 9. Count my minus signs. I have 2 of them, so I have a plus. 4 times 28 is 112. Add those together, and I have 3 plus or minus the square root of 121 over 2. What do we know about root 121? That's 11. So I'd have 3 plus or minus 11 over 2. Am I done? Nope. Why am I not done? Carrie, I think you were shaking your head no. Why have I not finished?
You have to simplify it the rest of the way.
Yes. If 3 plus 11 and 3 minus 11 is something you can simplify, then you need to do it. If it is 3 plus or minus something times I, like we had before, you can't put those together. If it's 3 plus or minus the square root of 2, you can't put that together. But if they're both rational, we put them together. So one answer is 3 plus 11 is 14, which gives us 7. The other answer is 3 minus 11, which is negative 8. So our two answers need to be 7 and negative 4. When you have integers like that, if you come back up to your original, oh yeah, two things that multiply to be negative 28 and add to be negative 3, I could have factored that as x minus 7 and x plus 4, and I would have gotten the same answers. You do need to read directions. Some of them will say use quadratic formula, some of them won't. Okay, same equation now, but now we're going to say that was x squared minus 3x minus 28, not equal to 0 now, but equal to y. And now we're going to put that one in on the graphing calculator and see what happens for that one. So I'll get my calculator back up here. First thing I'm going to do is clear my scratch pad, so menu and actions 1, and I want to delete everything, which is a 4, and yes, I really want to do that. Now I'm going to tab so I can enter my new equation. Which is, get that up higher still, sorry. X squared minus 3x minus 28. So x squared minus 3x minus 28, and hit enter. Oh, I can't see where it crosses the x. I can see where it crosses the x-axis, but I can't see the vertex. I'm not happy with the way it looks, so menu, and then I want to zoom in or out, and let's see, I want to zoom out some on this one, I think, and I'll try the center maybe about here. Okay, I'm getting closer. Another trick that you can do is, oh no, I don't want to do that, so escape out of that. Another trick you can do, if it works here, and it may not on this one, you can click on, depending on your version, and this may not be updated on my emulator here, you can click on this to be able to change the number that you want that to go to. I need to be lower than negative 18 to get to my vertex, so I'm not sure exactly what I want to pick. Maybe I'll just try negative 40 and see what happens. So I'm going to put in, use the negative sign this time, and 40, and then enter. Now I can see my vertex on my calculator screen, and I can see both at my x-intercepts. Everybody okay with that? I needed to have that because this says sketch a graph, label the zeros and the vertex. So I need to get my screen so I can see all three of those things on analyze the graph. And this one, the vertex is at the bottom of it. It's the lowest part of the parabola, so it is the minimum, left and right of it. And my vertex is 1.5, negative 30.25. So when I copy this sketch onto my problem set, I can label both of those coordinates. To get the x-intercepts, or the zeros, menu, we're still analyzing the graph. 0 is a choice on there, so that is what we want. So we pick choice 1. Okay, for one of these, we go to the left of it and to the right, so there's only one in there. And it says, oh, negative 4 means y is 0. Hey, that matches what we got. When y was 0 and we solved the equation, we got negative 4 as one of our answers. They better match. Then I'm going to do it again to get the other zeros. So menu, analyze graph, 0, go to the left and the right of it. And it says, oh, if x is 7, y is 0. 7 makes the equation come out to be equal 0, which is what we wanted when we solved the problem. So then what you would do with your problem set paper is to do the best that you can to copy a graph like that. Your vertex needs to be in the 4th quadrant, since that's what you see on your calculator screen. Kind of copy the same shape, more or less. Notice you want this x-intercept, the negative 4, 0, to be closer to the y-axis than the 7 is, so you kind of want it to, look decent. And then you label the 1.5, negative 30.25, and you label the 7, 0, and you label the negative 4, 0. Everybody okay with that? I think that's kind of fun, and we are going to start asking you some application questions as we progress on farther this semester. Some of them get kind of fun and silly. All right, you also are responsible for proving or deriving the quadratic formula. So take good notes. This will be on tests. It will be on problem sets over and over again. So first thing you don't get to do, when you prove or derive, no mental math steps. Every single step must be written down. That's what derive it means or prove it means. So you must actually write down ax squared plus bx plus c equals 0, exactly like it is. Next step, to complete the square, though, we want the constant on the other side, x is on one side, numbers on the other side. So the next step is going to be ax squared plus bx equals minus c. When we complete the square, we have to start with 1x squared. So the next thing you're going to do is to show that you are dividing each of those by a. So now we have 1x squared, which is what we want, plus something times x. Now we need to take half of that something that is times x. So we take the x, this was a plus b over a. So if we take half of b over a, we have b over 2a that we need to square. Thumbs up on screen, everybody good with that? All I did was I took half of b over a. Okay, then what needs to go in here is going to be b over 2a squared, right? So we can write that right here as plus b over 2a all squared. On the other side, I need to add the same thing, but to save a little bit of trouble writing that down, I am going to go ahead and say b over 2a times b over 2a is b times b in the numerator, 2a times 2a in the denominator, so 4a squared in the denominator, so that I added the same thing on both sides. This one was a little bit too confusing to me to just do it mental math, so I wanted to write it down one time I'm squaring it, the other time what I get when I square it, but they're really the same as each other. Okay, now I've got parentheses squared equals. So I need to get a common denominator on the right-hand side. That means I need 4a squared for my denominator. So this, and you must write that you're multiplying numerator and denominator by 4a. So that you're multiplying by 1. That means that what I have, and if I use the commutative property, I've got the b squared over 4a squared. And now I also have minus c times 4a, which is minus 4ac, all over 4a squared. So I switched the order and I did that multiplying. Now we get to take the square root of both sides. But when we do that, we know we have to take the plus or minus square root of that. So that means that I have x plus b over 2a, the parentheses squared went away, equals plus or minus square root of the numerator over square root of the denominator. Square root of 4ac, square root of 4 is 2, square root of a squared is 2a. One step left. Subtract b over 2a from both sides. But I've got a common denominator, so I can write it all with one denominator. And that is our quadratic formula that we want. Questions from anybody on that? Be sure you got that copied down. That is what you need to do on problem sets and on a test when we ask you for it.